Welcome to Module 3 of SAAS Mastery, where we're going to talk through some foundational concepts. We're going to be periodically updating resources over time as you have, questions on things that you'd like further clarification on. So just feel free to reach out to us if there are any pieces that remain unclear. But this part of the course, we're going to talk a lot about technology and different concepts that are going to set the stage for some of our future modules. So if you have to watch these a couple times just to get through everything, just it's very important that you understand the topics that we're going to talk through in these 4 lessons. So lesson 1 is understanding platforms and technical terms. The next lesson will talk a bit about computer languages. The third lesson will go through team roles and responsibilities once you look to begin your project. And lesson 4 is going to be around project schedule and monetization ideas. So lesson 1, let's talk through platforms and technical terms. So again, we're going to have downloadable resources here that we're updating periodically to translate a lot of the popular technical terms. We're going to update these as frequently as we can to make sure that any questions that you have are answered. But from a foundation concept, platforms, one of the key questions that you may be asked for, or that you would request from your developer or development team is, what architecture is my software going to run on? And when we talk through architecture, there are a lot of concepts that that we'll be weighing here, and one of those will be, is this going to be a desktop application that you're running? And by desktop application, you can think of it like Microsoft Office, right? You open up Microsoft Word, you double click on it, it opens an application that's installed to your computer. There are also command line applications where you access it by going through the command line of the computer, or maybe you double click on something and it shows one of those black prompts that that pops up that either asks for some more information or just does something on its own. The architecture for something like that is very different than can be very different from a desktop application. Many command line applications might run on servers versus desktops on end-user computers. Or is this going to be a cloud solution or application? And by cloud, I mean that it's hosted on somebody else's server, like, for example, Amazon Web Services, DigitalOcean, Microsoft Azure, Oracle Cloud Infrastructure, Heroku. There are a number of them that you just want to research to see pricing information, what types of SLAs or service level agreements that they have in terms of uptime. You just don't want to have your application go down and access is prevented to the users that you have. So things like this are going to feed into your what type of architecture that your software is going to have, what type of operating system, Windows or Linux or Mac, etc., which we'll get into. And then also you'll have to think through, well, where's the data for the software going to be stored? So it could be in a local file that's on the user's computer. So like if you think of Microsoft Word, for example, you create a Word document, you hit File Save, and a file is generated on your computer. It's not necessarily stored anywhere, in the cloud or anything, unless that's where you put it. But for the most part, it's saved on your computer. If it's not saved on your computer, it could be saved into what's called a relational database, which essentially is row and column storage, similar to spreadsheets, where if you think of a tab in a spreadsheet as being a table, and your data is stored in a series of rows and columns. One of the big components for relational databases is that each of the columns that you have are set in terms of the data types that could be stored in there. And by that, I just mean if you're storing numerical data versus text and so forth. So it's structured data storage. And the benefit to that is that you get your retrieval faster because there are a lot of operations that that can run more efficiently when they know what type of data is going to be in that particular column. There's also what's referred to as NoSQL, which stands for not only SQL in there. And then document databases. These are more unstructured in nature. You might have images, video, text that's stored there. Graph databases are another option, which is best for data where you're capturing relationships between the data. So if you could think of something like, for example, a platform like LinkedIn uses graph databases when you're thinking about, what's my second degree connection or third degree connection and so forth, as evaluating all your different relationships that you have and annotating them. That's a platform which will heavily use graph databases. Also next is container technology, and this is code that runs inside of a container. By container, what I mean is that it's a prepackaged module that allows you to replicate a specific setup for your technology. So what I mean by that is that you'll have things like your operating system, whether it's Windows, Linux, Mac. In there, you'll have any particular applications that you need installed in order to make that software run. All of its required dependencies are going to be inside of that container, and you can have multiple containers that are on a given server. So it can help you efficiently scale up many of your applications. So again, your standardized operating system, the software. By operating system, I mean the code that runs a computer or server. A lot of the popular ones are Windows, Linux, Mac. Inside of Linux, you have many different flavors of it, like you may have heard of, like Ubuntu Linux versus Oracle Linux versus Red Hat Linux, etc. Those are all types of a Linux operating system. There's also the option of what's called serverless technology. So obviously every single application that you're running on a cloud requires some type of server in order to run. So serverless is a little bit of a false advertising, but the concept of it is that you don't have to go and start sizing hardware specifications. You don't need to say, hey, allocate 4 cores of a processor and 16 gigabytes of RAM and this much hard drive space and all of that. You just deploy the code to a platform, and that platform goes and figures out, well, what is required in order to get this code to run. That way it's a lot less maintenance on your part. The one thing that I want to call out here is that if you do go the serverless route, just be very careful about what's called vendor lock-in. So a lot of the different vendors for serverless technology use either their own proprietary technology or they're using different commercial or open source products in order to make that happen. So if you do this on AWS, for example, Amazon Web Services, and then AWS hits you with a $1,000 bill to run it, and you say that's way too high, Microsoft will do this for $300. You can't necessarily just go and copy and paste your code over. There's some configuration that will need to be redone in order to port your code over to work on Microsoft instead of Amazon. Code repositories. So as you think about how you're going to store the code that's behind the software, there's several different hosted code storage platforms. The most popular ones are GitHub, GitLab, Bitbucket. Amazon has its own proprietary code storage software that if you subscribe to AWS that you can use and put the code on there. Essentially, you want to make sure that your code is centrally stored. And if you have multiple developers that are accessing it, everyone doesn't have their own set of files that they're working on where they can be out of sync. You want to make sure that the code is stored in one location, and that location is accessible to everybody working on development, and that it can be deployed in an efficient manner to wherever you need it deployed. Lastly, on this slide, we'll talk a little bit about automated deployment. So there's a concept called CI/CD, continuous integration, continuous deployment, and essentially that's just a structured approach to pushing your code from your code repository, like GitHub, for example, all the way to the server or servers that need that code. You want to make sure that everywhere where the code is pushed, that everyone's using the same version, for example, that it's all been tested to make sure that any new changes aren't breaking existing core functionality. So I just put that term out there. We can talk about it more in a future video, or we can put some resources out there if you want to know more about it. It's just more that we want to make sure that you understand the concept if it's brought up. So when you go to hire your developer, and we'll have some resources on questions to ask and things like that, but either they're going to ask you what technology platforms that you want your code built on, or you can always ask them for their own preferences and recommendations. Just keep in mind that, for example, if you're talking to a developer who develops in PHP, and we'll talk a little bit in the next video about what some of these terms and languages do and what it means, but and you say, hey, what preference or recommendation do you have? They're going to tell you write this in PHP because that's what they know, not necessarily that's the best language. So really when you're asking for recommendations, just make sure you take into account the biases that the person or group that you're asking may have, because you just don't want to build all your software on a specific type of technology and then find out that it's not going to scale to meet your needs, or you're going to need to change it later on. These are some of the core pieces that become very hard to change as you go through your development process. So keep in mind a few different things here. One, vendor lock-in. If you're leveraging any specific technology to a specific cloud vendor, and they decide to double their prices tomorrow, not saying it'll happen, but there's always the chance that something like that could happen. But if Amazon doubles its prices tomorrow, can you easily move to Microsoft or DigitalOcean or Heroku or vice versa? So you want to make sure that when the technology and software is built, it's built in such a way that it's not going to be a complete overhaul or recoding of your application in order to translate it to another. Also keep in mind ease of maintenance. So just because you've paid someone to go and build this technology for you, keep in mind that it's going to evolve over time. You're going to have updates that you'll need to make to the software itself. Is it going to be easy for you or a member of your team to manage that? Are you going to need to hire somebody to manage and maintain that? All this becomes considerations as you come up with your budget and how much you're thinking that this is going to cost you going forward. Also, do you need someone that's specialized in a certain position? Do you need someone that's database administrator? Do you need a server administrator, coders, testers, etc.? So the more specialized team members that you're going to need, obviously it's going to increase the cost to run the software and to maintain it. So you just want to keep in mind and think about, is something like that acceptable to you? If it's not, you want to make sure that you're very specific in your ask of the development team that, hey, I need someone who's non-technical to be able to maintain and manage as much of this as possible. And, lastly, just it's good. It's always good to get a sense of what the run costs are going to be for your software once it's deployed. You don't want to be in a position where you have $1,000 to spend on building an application. You spend $1,000, that's all the money you had, and now you find out it costs $5,000 in servers in order to, keep it running, and you don't have the money to stop. So, always either do your homework and look it up yourself. A lot of these vendors have pricing calculators on their websites where you can look to see, or ask the developer or the team that that you're bringing in to give you an estimate and to show you, hey, what is it that I need in order to keep the lights on here.